Hey YouTube, this is the power reflector circuit, which is a simple over unity circuit, and it doesn't violate any laws of physics, and you can replicate it yourself if you're interested in trying it. And it's just a way that I figured out how to do this with a relay and a signal generator. So I'll show you the circuit and then we'll show you some numbers. So quite simply, the circuit uses a source battery here. I'm using a 12 volt. And it's going to discharge through a load, and I'm using an inductive load here, which is this just hand wound toroid. And then after the toroid, the circuit's going to go into two capacitors, and these switches are going to be imagine these both connected this way, so these are both going to be in parallel. So this power is going to go through the toroid. It's going to fill up both of these capacitors. These are going to reach 12 volts, and then these switches are going to flip-flop, and then these capacitors are now going to be in series. So the 12 volt capacitors will now have 24 volts, which will push this power backwards through the load and into the battery. So the power that comes out of the battery goes through the load two times. It goes this way to fill the capacitors, and then comes back when the capacitor is done. Now everyone knows you only recover about half the power from the capacitor, but you still get a factor of about 3 times the load power that you're going to see in the battery power, or maybe 2 times. It just depends on how it's set up. Okay, so this is a simple way of doing this using a double pole, double throw relay. You could also use 2 single pole relays, and you want to trigger them using a signal generator. So we'll set this one at 30 hertz, 70% duty. So that means 70% of the time the capacitors are going to be in series, 30% of the time they're going to be in parallel. And these numbers can be played with. I've just found that's kind of a good spot. Okay, the signal generators triggering this solid state relay, which then triggers the mechanical relay. And the power is going to come out of this battery. We're going to measure how much power is coming on the power analyzer here, power meter. Okay, and then really it's just going to go through this red lead. It's going to go through a clamp meter. It's going to measure on the scope the current. And then there's probes across the toroid where we're going to measure the voltage. And the important thing with the AC power here, which is it's going to go back and forth, so it's both directions, is that I've got to use the RMS voltage and the RMS current values, since the values are both positive and negative. Now the average current that you're going to see here isn't RMS, it's just average, but that's because we're using this 12 volt battery and we want to know the net amperage going out of the battery. So it's actually going to send a lot more current than we're seeing on the meter, but we're just going to see the net amount here. Okay, so let's turn this on. You can hear that clicking. Okay, you can see on the screen, the green line here is the current, and you can see how it's both above and below the axes. So this would be kind of the 0 point right here where it's flat. There's power going in and then power coming back. And then the yellow line is the voltage across the coil. Okay, so you can see right here the current is about, so it's 68 millivolts, but you got to multiply that by 100, so it's actually about 6.8 amps. Okay, so we're going to call 6.8 amps the RMS current, and then the voltage you see here is about 5 volts. So it's again going to be both positive and negative. You can see it kind of flip-flopping here. And there's obviously spikes here because of the inductive nature of it. You can see the max is actually 72. The min is minus 60, and then it's 90. But the RMS is really about 5 volts, okay? So these are the numbers we get then. RMS voltage times RMS current gives us 32.2 watts going through that toroid. Now the battery here is seeing on average about 1.2 amps. Okay, and so multiplied by the battery voltage gives us about 13 watts out. Then, since the battery is discharging 13 watts and the load's seeing 32 watts, the COP is 2.4, which I think is pretty spectacular. I'll turn that off. Let's go back to 0. This is just a simple circuit though to really reuse the same power out of the battery in 2 directions through the load. So you guys can play with this. Let me know if you've got good results. I'll show you some other ways to run this. Ultimately, I'd like to design this to run off pure solid state electronics and not an analog relay. This is just an easy way to do it. So with that, thanks for watching. Leave me comments if you've got them or if you've got questions. Thank you.